So it gets a little bit more involved when the denominators aren't the same. So let's say you have something like x plus 1 over x, and I want to, let's say, subtract this time x over x plus 2. And let's say we're told that x is not equal to 0, x is not equal to negative 2. Okay, well, just like with fractions, when we have rational expressions, if we have a over b minus c over d, I want to make these the same. I can't just make them the same because I want them to be the same. So what I can do is if I make the bottoms both db by multiplying by d over d and b over b, I get the following, dA minus cb over db. And similarly, if I were to have AB plus CD, I could do the same to get dA plus CB over dB. There's really only a couple tricks. You might see this as a trick, or you might see this as a rule. We could just memorize this as a rule, not as easy to remember as maybe the idea of multiplying by something that's equal to 1 here and here. There's really only two major tricks we always have to keep in mind in classes like this, and that's that we can always add 0 and we could always multiply by 1. These do not seem profound. I mean, it's kind of obvious that you can multiply by 1 without changing anything, and add 0 without changing anything. If you've dealt with 1 and 0 enough, that might be clear. But this is a great example of multiplying by 1 in order to get something. However, this is still not the example we're doing. This is just sort of the formula for doing this in general. Let's look at this right now. Okay, so I want to subtract. So what I'm going to do, and I'm going to write down here to give myself some room, is I'll multiply by x plus 2 over there. And I have this, I'll multiply by x over x. What's that going to do? Well, it's going to make the denominators equal. So over here, I'm going to have x plus 2 times x plus 1 over that minus x squared over that. These denominators are now the same. So what do I have? I have x plus 2 times x plus 1 minus x squared over x plus 2 times x. Now, I don't like this form. You might say this is a beautiful form. Look, that's already factored. Well, no, the top is not factored. A little piece of the top is factored. If I wanted to set the top to 0, that would not help me at all. So in a situation like that, if I want to simplify all the way, I actually do want to multiply this out because it will make it simpler. This will give me 3x plus 2 divided by x times x plus 2. And now I have things in a very simplified form. Much simpler than having this difference up here. So yeah, this might look like it's factored, but having a single piece of a sum or a difference factored doesn't really do very much for me, unless like it appears in each of the terms, which neither of these appear over here. So that's why I say, hey, multiply this out and maybe you'll get something simpler. And look, we did. The quadratic went away completely and we got a simpler expression here. So that's a nice expression of subtracting when we don't have a common denominator.